Righto, Year 12, I just want to go over some of the questions that we were doing today because I know some of you might have found them difficult. And in particular, question 5 is extremely difficult, and I don't want you to worry too much about it because I don't think you're going to get a question like it. And also, I'm pretty sure that Margaret's answer in the back is wrong. But mainly also for some students who weren't here, so I'm going to quickly go over some of these. You should, if you have read the notes, been able to do question 1. But I'm going to pick up here with question 2, and I'm going to do it differently from the way that Margaret does her example question. So her example question for some of the ones in 2 is here. And she does this thing with fractions, and although you can do that, I think it's a little bit clunky, and I'm going to show you what I perceive to be a better way. So let's have a look at 2b here. Now, I've got to integrate dx, and that shouldn't worry you, on the square root of 1 minus 4x squared. Now, straight away, that 4x squared is going to pose me problems because if I look back here, all of these integrations just have x. So I just want x, or I don't want a 4 in front of it. Now, Margaret, you can get convoluted in a way to get rid of that, but here's what I'm going to do. I'm going to let u equal 2x, the square root of that 4x squared. Therefore, u squared equals 4x squared. Okay, so I can write my integration as dx over the square root of 1 minus u squared. Now that's going to be really easy to integrate if only I had du up the top. Well, let's go back here and we can go, du dx is a derivative of this, which is 2, and that's a constant. And that makes it really easy. So du equals 2 dx. So up here, I'm now going to do a little bit of hokey pokey. I'm going to put 2 dx in there so I can change it to du. And if I put 2 in, I've got to take 2 out, and I divide that. So I get a half the integral now with respect to u. And that's really easy because that's a half inverse sine of u. And what was u? 2x. And don't forget your constant. And I'm pretty sure that's the answer. I'm just checking, I've got the book open here. And question 2b, there we go. Now I think that's a lot easier than trying to somehow get rid of that 4. Margaret's example up here with all this fraction, yeah, it's doable, but it's pretty ugly. Why don't I take one that's similar to the one Margaret did? So she's got 4 plus 9x squared. Why don't I take this 1 plus 9x squared and I'll do 2d and show you why this is so much easier. So 2d, and we've got the integral of dx on 1 plus 9x squared. Just double check. Righto. So I let u equal 3x, so therefore u squared equals 9x squared, so just square root of that 9x squared. Du dx equals 3, so du equals 3x. And now it's easy because I just put the 3 in, I take the 3 out, so I've done that. I put 3 in, I took 3 out, And now I've got 1 plus u squared. And 1/3 du on 1 plus u squared. And that's easy because that's 1/3 inverse tan u plus my c. And I put in my substitution, which is 3x plus c. And to me, that makes so much more sense. And that's, what was that? 2D. Just checking my answer. Yes, that makes so much more sense. So look at that beautiful substitution, which is a skill you need to have as an Extension 1 student, rather than dealing with those fractions and messing it up. It just makes it so much simpler. Excuse me. Righto. Let's have a look at another one. And here's another one I did. And in class today. So it was 3h. And it was a bit difficult because now we wanted these exact values. So 3h, I've got 1/3 and negative 1/3. And I've got dx on the square root of 4 minus 9x squared. Well, I'm going to let u equal 3x. Therefore, u squared equals 9x squared. Du dx equals 3. So du equals 3 dx. But I'm also going to have to change the parameters because now I have these parameters in. So when x equals 1/3, u equals 3 times that, 1. And when x equals negative 1/3, u will equal 3 times that, negative 1. And now I have all that I need. So equals. Let's change the parameters. 1 to negative 1. Let's put 3 in and take 3 out. And then I've got 4 minus u squared. And finally, I've got my third. I've got my 1, my minus 1. I've got my du. And I've got the square root of 4 minus u squared. So, 1/3. And you can just shoot right to your formula sheet and see that what this 4 is going to do to it. So let's shoot up here to where they are in the text. And we can see that's what we want. The x is going to be on the square root of that. So here I go inverse sine x on the square root of 4, that's 2, from 1 to minus 1. Oh, yes. So 1/3 inverse sine of 1/2 minus inverse sine of negative 1/2. Now this is where you need to be a little bit smart because we're doing the inverse function, and remember, we're doing the inverse function from 1 or minus 1 to 1, and for sine, oh gee, that's terrible. I'll just get rid of that. For sine, that goes like that. So we're going to get an acute value here, and we're going to get an acute value here for 1/2. I wonder what that acute value is. Well, I'm just going to draw my right angled triangle, 1, 2, and this is going to be pi on 6. There's my right angle. You can put the root 3 in if you want. You can put the pi on 3 down here. So 1/3, I'm going to get here the positive a half, I'm going to get positive pi on 6. Sign is opposite. And over here, the negative a half, I'm going to get negative pi on 6. So that's 1/3 pi on 6 plus pi on 6, which equals 1/3 times 2 pi on 6, which equals pi on 9 units. Oh well, I know we're finding area, but I'll just leave it as pi on 9. So they're the ones you need to be able to do. I'm now, well, you can go ahead and finish those. I'm now going to make another video about question 5. So I'm just going to stop that one there.